What's up, guys? How are you doing? In today's lesson, we're gonna discuss about double or compound inequalities, wherein we're going to compare the or and and. So, are you ready? Let's go! Now, we're gonna discuss on how to solve compound inequalities. What do you mean by compound inequalities? A compound inequality contains at least two inequalities that are separated by and or or. Okay, for compound inequalities and, the graph of a compound inequality with and represents the intersection of the graph of the inequalities. Now, the question is, what do you mean by intersection? Okay, so let's say for example, we have two sets A and B. What do you mean by the intersection of two sets A and B? The intersection of two sets A and B is defined to be the set of all elements that belong to both A and B. So meaning to say, the common elements between two sets A and B. Okay, so let's say for example, we have this solution set x greater than A. This is the solution for one set, and x is less than B. Okay, it's another solution. Okay, so we have a real number line. We have 2 points, point A and point B. Now we're going to graph the solutions in a real number line for x greater than A. This is the graph. So I mean to say the solution set starts from point A to positive infinity. No? Okay. What about x less than B? So the solution set is from negative infinity to point B. Since we're using and, we'll be getting the intersection of these solutions, of the solution sets, two solution sets. No? So the intersection would be is from all real numbers between point A and point B, and taking note, point A and point B are not included. Okay, so that's and. So the interval notation, the solution set for interval notation is this one, no? A and B. So we're using the parentheses. It shows that A and B are not included. All right, let's go to or. Compound inequalities or. The graph of a compound inequality with an or represents the union of the graph of the inequalities. Okay, we'll be using union this time. What's the difference between union and intersection? The union of two sets A and B is defined to be the set of all elements that belong to A or to B. Okay, take note, or belongs to A or B or both. Alright, so we will have to graph the solution sets, no? This one, x less than A and x greater than B. So we have a real number line. Of course, 2 points, the point A and the point B. First, we will graph x less than A. So what's the graph? Yeah, that's it, no? So the graph is, the solution set, is from negative infinity to point A. But point is not included because we're using the less than. So meaning we have an open circle for A, and B is also an open circle. Let's go to the graph of x is greater than B. That's a graph, no? From point B to positive infinity. Now what's the solution set since we're using or? Alright, that's it. So the solution set will be from negative infinity going to A, and from B to positive infinity. Right, so we have the positive infinity to the right, negative infinity to the left. So the interval notation in the solution set, interval notation would be from negative infinity to A is not included, union from B to positive infinity, but B is not included. So this is the solution set. Alright, any question? Okay, let's go to example for n. Okay, so we have two inequalities here. Okay, so first, the 3x plus 8 is less than 8, and 4x plus 4 is greater than negative 32. We will solve first this one. So all you have to do is to subtract both sides by 8. So we have 3x plus 8 minus 8 is less than or equal to x minus 8. Then we have to simplify. 3x is less than x minus 8. Then we have to simplify this one. So we have to subtract both sides by x. So 3x minus x, that's 2x is less than, so this is 0, negative 8. This time we'll divide both sides by negative 2 to eliminate 2. That's it. So our final answer would be x is less than negative 4. Alright, let's go to second example. 4x plus 4 is greater than negative 32. We're going to subtract both sides by negative 4. So we have 4x plus 4 minus 4 is greater than negative 32 minus 4. And by the way, in other videos in YouTube, they're using the vertical method in adding or subtracting numbers. But in my case, I'm using the horizontal method. No, it's still the same. Okay, so we're going to simplify or combine like terms. We have 4x. This 0 is greater than 32 minus 4. Negative 32 minus, or negative 32 plus negative 4, that's negative 36. Okay, we will eliminate 4 by dividing both sides by 4. Or you can multiply this both sides by 1/4. No? So in our case, we're dividing this by 4. So cancel. So we have now x is negative 36 divided by 4, that's negative 9. Okay, now we're going to graph our solutions. We have the number line. Of course, we have points, 0.9, negative 9, and negative 4. Alright, let's start with x less than negative 4. This is the graph. So meaning in interval notation, this is from negative infinity to negative 4. But take note, negative 4 is not included. Next, we have x greater than negative 9. Of course, from negative 9 to positive infinity. Since we're using and, we will get the intersection. Okay, so what's the intersection? The intersection would be this one. From negative 9 to negative 4 exclusive. So meaning to say negative 9 is not included and negative 4 is not included. For interval notation, we have this solution set. From negative 9 to negative 4, we're using the parentheses. No? I'm using the parentheses, the open and close parentheses. No? So meaning to say negative 9 and negative 4 is not included. Alright? Now, let's go to example number 2. Negative 5 less than 3x plus 4 and 3x plus 4 is less than 10. This is the combined form of the two inequalities. 3x plus 4 is greater than negative 5 but less than 10. Okay, so we'll start from the middle. We're going to eliminate 4, so subtract 4 to the right and to the left, and of course to the middle. So that's negative 5 minus 4 is less than 3x plus 4 minus 4 is less than 10 minus 4. So this is 0. So negative 5, negative 4, that's negative 9. We're going to simplify. So we have now 3x because this is 0 and 10 minus 4, that's 6. By dividing by 3 in the middle, so we have to eliminate 3, so we will divide also 6 by 3 and negative 9 by 3. So simplify. So this is x is greater than negative 3 but less than 3. So this is the solution set. Okay, we're going to graph the solution set. So we have the number line, we have point negative 3 and 0.3. Alright, so x is greater than negative 3, this is the graph. X is less than 3, this is the graph. Now take note that this is and, so we're going to get the intersection of the graph, the two graphs. So we have this one. So the solution set in interval notation is negative 3 to positive 3. Take note that negative 3 and 3 are not included. Now let's go to example number 3. So we have this 2 minus 3x is greater than negative 7 but less than or equal to 8. Okay, we will start from the middle. So we're going to subtract 2 at the middle and then from the right and from the left. So we have negative 7 minus 2 is less than 2 minus 2 minus 3x is less than or equal to 8 minus 2. By simplifying, we have the 0, so bring down 3x at the middle, 8 minus 2, that's 6, and negative 7 minus 2, that's negative 9. Now, to eliminate negative 3, we are going to divide negative 3 from the middle to the right and from the right and from the left. So we have negative 3, that's cancel. So 6 divided by negative 3 and negative 9 divided by negative 3. So we have x is greater or equal to x is less than 3 but greater or equal to negative 2. Take note that if we are dividing negative numbers in this inequality, so the what you call that, the opening, or we are going to reverse the inequality symbol. So instead of less than or equal to, it will become greater than or equal to. Instead of greater than, so it should be less than. Alright? Okay. Now, since negative 2 is smaller than 3, so it is proper that we're going to place negative 2, okay, first, and then the higher number is to the right. So we have this one, x is greater or equal to negative 2 but less than 3. This is the standard on how to write the solution set. So by graphing, we have the real number line. Okay, so we have 2 points, negative 2, and the other one is 3. Notice that negative 3 is open circle, while negative 2 is closed circle because of the greater than or equal to. But in the case of 3, that's less than, so it's an open circle. So we'll see the graph. The graph of x is greater than negative 2, so meaning to say from negative 2 to positive infinity, and x is less than 3, so the graph is from negative infinity to positive 3. Since this is end, we'll be getting the intersection. So what's the intersection? That's it, no? So the intersection, the solution set is from negative 2 going to 3. Take note that negative 2 is included but not 3. Okay, so the interval notation, solution set for interval notation is, yeah, negative 2 to 3. Negative 2 is included but 3 is not included. Alright, any question? How to solve double inequalities? Guys, this time, let's go to example number 1 for OR. We have 3x plus 4 is greater than 18, or 4x minus 1 is less than 23. Now we're going to solve first this inequality. We're going to subtract 4 from both sides. We have 3x plus 4 minus 4 is greater than, is greater than 19 minus 4. So this is 0, so we have 3x is greater than 15. Now to eliminate 3, we're going to divide all sides by 3. So this is cancel. X now is equal to 15 divided by 3, that's 5. So x is greater than 5. Okay, let's go to example, to another inequality. So for x minus 1 is less than 23. We have to add both sides by 1 to eliminate negative 1. So we have for x minus 1 plus 1 is less than 23 plus 1. So this is 0. We have for x is less than 24. We're going to eliminate 4, so divide both sides by 4, cancel. So 24 divided by 4, that's 6. So we have x is less than 6. Okay, we'll see the graph. Okay, we have a number line, and the 2 points are 5, and the other one is 6. Okay, take note that we're using the open circle because our inequality is greater than or less than. Okay, so meaning 5 and 6 are not included. So we'll graph the solution set. Of course, this is positive and negative infinity to the right of 6 and to the left of 6. Okay, so we have x greater than 5, meaning from 5 to positive infinity. X is less than 6, meaning from 6 to negative infinity. Now, class, take note that this is a union. Okay, so meaning or, we're using or. So we'll be getting maybe in this the solution set would be this one or both. Okay, so the general solution set is okay from negative infinity to positive infinity. So this is the final answer. Okay, so let's go to example number 2 for or. Okay, we have negative 6x plus 2 is less than 20, or 12x plus 11 is less than negative 13. Okay, we will solve this first. So we have subtract 2 from both sides. We have negative 6 plus 2 minus 2 is less than 20 minus 2. So that's negative 6x is less than 18. Okay, because 20 minus 2, that's 18. We'll divide both sides by negative 6. It's 1. Okay, so this cancel. X now is, take note that we are dividing this by negative numbers. So we're going to change the direction of the inequality symbol, which is from less than, it will become greater than. So our solution set would be x is greater than negative 3 because 18 divided by negative 6, that's negative 3. Okay, let's go to the second inequality. So we're going to subtract both sides by 11. So 12x plus 11 minus 11 is less than negative 13 minus 11. To simplify, we have 12x is less than negative 24. So we will divide, or we will have to eliminate the 12x. So we're going to divide both sides by 12. So this 12x divided by 12 is less than negative 24 divided by 12. So our solution set would be x is less than negative 2. Okay, we'll see the graph. That's the we will graph this solution set in a real number line. So this point negative 3, this one is negative 2. Okay, we'll graph the of course this positive and negative infinity. Okay, this is the graph of x less than negative 2 from negative infinity to negative 2. The second one is from negative 3 to positive infinity. Since this is or, we'll be getting the union. So what's the solution set? That's it, no? Okay, so meaning the solution set in interval notation is negative infinity to positive infinity. Okay, any question, guys? So I think that's it for today. I hope you enjoyed watching my videos. Don't forget to subscribe to my YouTube channel for more exciting videos about mathematics. That's the only way you can help us grow. Okay, thank you so much and good luck.